Okay, right now I need you to flip in your packet to page 41. And please notice tonight's homework is update your calendar for homework to match page 45 to 47. If it doesn't already say that, or I don't know why you have to switch it, but somehow 45 to 47 is tonight. Please spend about 5-ish minutes, 5 to 10 minutes completing this warm-up on page 41. Rank them, and I need an explanation for that. So please pause the video at this time. All right. We are comparing a whole bunch of different scenarios here. So in order to rank them and explain, what you really need to do here is to find a z-score for each one. So because you need to compare different situations to each other, and the easiest way to do that is to normalize them or standardize them. So we're going to standardize them by giving each one a z-score. So this one here, you got 1,243 red loops. The mean is 800 with a standard deviation of 120. So that gives you a z-score of 3.69. So that's pretty unusual. You're over 3 standard deviations above the mean. So that's going to definitely be one of the higher ranks. Maybe not the highest, but a higher. The weight of house cats are normally distributed with a mean of 10 pounds and a standard deviation of 2.5. Big boy over there has a weight of 6 pounds. So 6 minus the mean of 10 over standard deviation of 2.1 is going to be below the mean. So 1.90 standard deviations below the mean. So that's it's definitely a lower number in terms of rank. Battery normally distributed with a mean of 40, standard deviation of 1.2, and it died after 20 hours. So if the mean is 40, that was a very unusual situation here. So in fact, it's negative 16.67 standard deviation below the mean. So there was definitely something wrong with those batteries. Just made this go away. Let's go back up. Okay. Human fingernail growth. A neighbor's thumbnail grew this year without breaking and 4.6 centimeters long. That's disgusting. But anyway, 4.6 centimeters long. Probably curling under at this point. Mean growth of 3.5. Standard deviation of 0.63. So find that z-score. And that z-score is 1.75. So again, compared to the average, it's not really that terribly unusual. E, my little brother was digging a garden, found an earthworm that was 35 centimeters long. So that's our X. And again, yuck. The length of the earthworms is normally distributed with a mean length of 14, so that's kind of big, and a standard deviation of 5.3. But it is a pretty big standard deviation here, a big spread between. But that's a 3.96 z-scores above the mean. So again, quite unusual. Mean length of human pregnancy is 268 days with a standard deviation of 16. Whoops. Ant delivered after 245 days, so that's below the mean because she delivered early. Minus 268 divided by 16 gave a z-score of negative 1.44. So then you're going to just take these and stick them in order. So now, it's asking which is the most unusual. Well, we don't really care about positive or negative here. We're caring about how far from the mean. So the most unusual, in my opinion, is 1. It's 16.670 standard deviations below the mean. The next number, again, ignore positive or negative here when you're determining this, is rank of 2 is 3.96. 3.96, it's rank of 2. The 3.69 is a rank of 3. 1.90, I know it's negative, but it's still 1.90 below the mean, is a rank of 4. So this is just which is or is not the most unusual. 5 would be letter D at 1.75. So again, the closer you're getting to the mean, the more normal it is. And negative 1.44 is a rank of 6. Here are your homework answers from last night. Calculating the z-score. And then assuming it's normally distributed, what percentage of the time does it make more than this amount or less than this amount? This is where you're going to use the chart. Again, when you do z-scores, you want this to be 2.88 when you're using the chart. If you're using the calculator, who cares? But again, you're either going to be looking up in your chart 2.8 and then 0.08 and find the number here. Which should be approximately 0.9980. Or you are using, again, that's for less than, because that chart reads to the left, so it's everything less than that percentage. Or you do normal CDF for, to make more than this amount, 2.88, 1 e to the 99th power, 0 and 1, so that's min, max, mean, standard deviation, and it should give you 0.9980, and then the complement of that 1 minus that, it's going to give you less than that amount. Sorry, more. I apologize. More than that amount is 0.2% or 0.00002, or 0.9980 for the other portion. Notice for 3 and 4, you're calculating z-scores first, and then you are going to find the percentages. So you can go directly in the calculator for normal CDF. For minimum is negative 1.66, maximum is 1.47, comma 0, comma 1. Or you look up those percentages in the chart and subtract them because you're trying to find in between. For 11, find the z-score of negative 1.22. So anything greater than that is going to be, if a company needs to break even, how likely is it the company to make a profit? Where's my homework answers? That one doesn't look right to me. Yeah. But your negative 1.22 is here. That's your break even. So this is losing money, and then to the right of it is gaining money. So I think that that's going to be bigger than that. It's going to be like 89%, not 11%, because that would be the percentage of losing money, not the making the profit. IQ scores between 90 and 109 are average. Find the two z-scores. Either look them each on the chart and subtract, or you do normal CDF between negative 0.67 and 0.6. Percentage that are genius, 2.33%. Sorry, a z-score of 2.33. So again, you're doing normal CDF of 2.33, 1 e to the 99th power, and you get 0.0001. Or, sorry, it must be 0.0100, because that is 1%. Alternatively, go to 2.3 in your chart and 0.03 up here, and where they intersect is the area to the left, and 1 minus that would be the area to the right, which would be 0.01 or 1%. You calculate the z-score for number 7, and number 8, IQ score higher than Einstein is a very small probability. So again, this is in the calculator normal CDF of 4, 1 e to the 99th power, 0 and 1, and it is approximately 0. It's this very small number. You're going to see like 3.168 e to the negative 1, 2, 3, 4, like 5 power. And that essentially means 0. All right. Should we send out a certificate? Is what your homework is. The homework, your classwork right now. So we would like you right now to complete pages 43 and 44. And it's going to take you about 15 minutes to do so. So please pause the video at this time and complete that. Okay, we are back. What percentage of scores are between 7.69 and 11.1? So you have to find those z-scores. So 7.69 minus the mean, which is 9.44, over 1.75. And that gives you a z-score of negative 1.00. Other one, 11.19 minus 9.44 over 1.75 gives you a z-score of 1. So percentage of scores between -1 and +1, you don't even need the table of random, the normal distribution table, the z-score table, or normal CDF for this, because you know within one standard deviation of the mean is 68%. So it should be 68%. If you use the chart or you use the table, if you use the table or use a calculator, it's 0.6827. But it's 60, you're good with that 68, 95, 99.7 rule, so you can go ahead and do that. Certificates are given to students who score in the top 2.5%. So top 2.5%, if you remember the normal curve and the 68, 95, 99.7 rule, this is one standard deviation is 34, 13.5, 2.35, and 0.15%. So this is 2 standard deviations right here above the mean, where we're looking at the top 2.5% of taking the test. So you're going to, regarding your request about Fred's test score, you're going to comment on that. And basically, you're just saying if you were 2 standard deviations above the mean, Fred scored 2 standard deviations above the mean there, then he's going to get approximately just give me 1 second, I'm just reading it. So 2 standard deviations of the mean, we're just looking at the z-score formula, equals x, which is the score he would have gotten, minus the mean, which is 9.44, over 1.75. That is a good way of solving for this. So 2 times 1.75 plus 9.44 means he should have gotten at least a 12.94 on the test to receive the certificate. He received 13.1, Fred. So he should have received that certificate. And should call since he hasn't gotten yet. So what you need to provide here is a justification, and this is a good justification. And now they want you to, part of this was, I said something like he will receive a certificate since the lowest number to receive a certificate is 2 standard deviations above the mean, which is 12.94, and since you received a 13.1, either it has been you haven't received it yet, or it's been lost in the mail, so we will send you a new one. Today's homework, you're going to start right now. Just make sure there's nothing below here. Nope, and that's where you're writing your quick letter response supporting your answer. Is page 45 through 47. I believe you're updating it because I think we assigned way, way, way more problems than that. This is going to take you a good amount of time. Please make sure you're plugging in, you're getting your z-scores, and you're finding your areas under the curve, which is the probability for each of these, and showing your supporting work. All right, and you have review in class tomorrow and a quiz the next day.